Hello everyone, welcome to the presentation on ohm meters. In this video lecture, we are going to see how to measure different resistances. What are different types of resistances? How do we classify the resistances? And what are different methods for measurements of those different types of resistances? And the basic ohm meter construction and working. I am Swati Polasa, Sanjay, lecturer in Electrical and Electronics Engineering, Sanjay Gandhi Government Polytechnic, Adilabad. So let us bring me back from known to unknown. Let us try to discuss on what is a resistance. Resistance is the property of material due to which it opposes the flow of electric current through it. So it clearly means that resistance is an element which opposes the flow of current. When current flows through the resistance, it simply converts the form from electrical energy form from electrical to thermal. You can see some images, some photographs of different resistances. You must have seen these resistances in your lab. Of course, may not these, but we have some images here of different resistances. Now it is represented by symbol R and is measured in ohms. So the units of resistance is ohms. So here actually the element is named as resistor and the property of the element is resistance. We can see different types of resistors. This is just for revision of your previous semester. So we have different types of resistors. First, they are categorized to linear resistor and non-linear resistors. Non-linear resistors are further categorized to thermistor, photoresistor, this is light dependent resistor in other words, and varistor resistor and surface mount resistors. So these are non-linear resistors. Coming to linear resistors, we have fixed resistors and variable resistors. And variable resistors further categorized to potentiometer, rheostat, and trimmer resistors. Potentiometer, rheostat, and trimmer resistors. You can see the images. You must have seen these rheostats in laboratory. Coming to the fixed resistors, we have these resistors in very compact form and they are further categorized to thin film resistors, thick film resistors, carbon composition resistors, wire wound resistors. So fixed resistors are wire wound resistors, carbon composition resistors, thick film resistors, and thin film resistors. These thin film resistors are further categorized to metal film resistors and carbon film resistors. Coming to the thick film, we have fusible resistors, cermet film resistors, metal oxide resistors. So in this way, we have different types of resistors. This is just for a revision and to grab your attention. So you must have already seen all these things in your previous semester. Now, coming to the perception of measurement, we categorize resistors in this manner. Based on measurement, the resistance is classified into three main groups. They are low resistance, medium resistance, and high resistance. So let us see it once again. Based on measurement, the resistance is classified into low resistance, medium resistance, and high resistance. So what type of resistance come under low, and what type do come under medium, and what type do come under high? Let us see that in our next slides. First one is the low resistance. So the resistances below the value of 1 ohm are classified as low resistances, which means the resistances which are less than 1 ohm come under low resistance. Examples, armature of DC machine will have very low resistance, and series winding of large machines also do have very less resistance, that too less than 1 ohm. So they all are considered as low resistances. Coming to medium resistance, resistances between 1 ohm to 100 kilo ohm are classified into medium resistances. So from 0 to 1, low, 1 to 100 kilo ohm comes under medium resistances. So we have resistances of different appliances which are in between 1 ohm to 100 kilo ohms. We have rheostats also. We have shunt field windings. So they come under medium resistances. Coming to high resistance, obviously it is more than 100 kilo ohms. So the resistance is more than 100 kilo ohms are classified as high resistance. The resistance of different insulators come under high resistances. Now let us see different methods used for measurement of different types of resistances which we have seen so far. Coming to the measurement of low resistance is measured with Kelvin double bridge. So this is one method to measure low resistance, Kelvin double bridge. And we have another method which is loss of charge method. By using any of these two methods, we can measure low resistance. Coming to the measurement of medium resistance. Medium resistance is measured by Wheatstone bridge meter. I'm sure you're aware of Wheatstone bridge. So using that Wheatstone bridge method, we can easily measure the medium resistance. And we have voltmeter, ammeter method. And also we have ohmmeter, which we are going to see in detail in this video lecture. Let me repeat the measurement of medium resistance once again. Medium resistance can be measured by Wheatstone bridge method, voltmeter, ammeter method, and ohmmeter method. Then how do we measure high resistance? High resistance is measured by Megger. So this is also called as insulation tester. So we use Megger to measure resistances more than 100 kilo ohms. So let us discuss few points here. Can anyone state or can anyone recollect what is Ohm's law? And how can we use this? Can we use this Ohm's law for measurement of resistance? Answer would be yes. In fact, Ohm's law is basis in all direct methods of measurement of resistance. So in this slide, we see that Ohm's law is used for measurement of resistance using direct methods. That means volt ampere method. So what is this volt ampere method? According to Ohm's law, voltage across an element is proportional to, that to resistive element is proportional to current through it. Or else we can say that V is equals to some constant into I, and that constant is what we called as resistance. So resistance is equals to voltage by current. This is very simple formula you must have learned in previous semester. Hence, the direct measurement of resistance means we simply use a voltmeter and an ammeter. We give some EMF, some voltage source to the resistor whose resistance you want to measure. Then take the readings of voltmeter and ammeter. Then just simply divide V to I. You will get R value. So measurement of ratio of voltage drop across the resistance to current flowing through it will give you resistance. So this method is termed as volt ampere method or voltage drop test. Let me give you the circuit diagram of the same. So actually we have a source and we have an unknown resistor whose resistance is not known, and we just want to find out the resistance value for that using this direct method. How we use, let us see. We place an ammeter in series and a voltmeter in parallel. This is ammeter and this is voltmeter. So you have given some voltage, so then you have good deflection of ammeter here and a good deflection of voltmeter here. So we use an ammeter here and a voltmeter here and some variable voltage source. Now this is the resistance whose resistor whose resistance value is not known. What we do is we just adjust the voltage, we increase the voltage to some value, take the reading of voltmeter, say the reading for one value of the position of variable voltage source. We got one voltmeter reading as V1 and another voltmeter reading, ammeter reading as I1. Similarly, you do change the values of input voltage to 2 to 3 values. Get the voltmeter reading and ammeter reading for the same condition. like this, then you will observe that V1 by I1, it equals V2 by I2, it equals V3 by I3, and these values are nothing but the value of resistance. Hence, we have calculated the resistance. In this way, we use volt ammeter method, volt ampere method for measurement of resistances. Hope you're clear with this. It is a very simple method. Now we'll see this measurement of medium resistances. Measurement of medium resistances is, as we have seen it already, that we use Wheatstone bridge, voltmeter ammeter method or volt ampere method, and the other one is Ohmmeter method. So this Ohmmeter method is what we are going to see in further slides. So what is an ohmmeter? An ohmmeter is an electrical instrument that measures electrical resistance. Let's have a look on image of a practical ohmmeter. So this is a photograph of a practical ohmmeter. As you can see that this ohmmeter, of course, here this meter measures resistance as well as capacitance values. Let us concentrate on resistance values here. Okay. And we have different ranges here. You can set the range and you can measure the resistance here. Now, let us know more about ohmmeter, basic ohmmeter. Basic ohmmeter is a permanent magnet moving coil instrument with a series resistance. We know that a permanent magnet moving coil instrument is an instrument which is very sensitive. It is capable of measuring small amounts of current, and this permanent magnet moving coil meter will have permanent magnet stationary and coil is attached to the spindle, and coil comes under a moving system. The deflection of permanent magnet moving coil is proportional to the current through it. This is what we have studied about permanent magnet moving coil. Just having a glimpse again. Now it gives, now we use permanent magnet moving coil for our basic ohmmeter. Now the basic ohmmeter gives approximate value of resistance. It requires practically no adjustment. The permanent magnet moving coil instrument construction and working were studied already and we have discussed it again. Now, the basic circuit of ohmmeter will look something like this. Very simple series circuit you see here. There is a voltage source. There is some resistance called as R0. And we have meter resistance. This is a meter. Meter resistance is Rm. And Rx is the unknown resistor. Rx is what we call as unknown resistor. We are trying to measure the value of Rx. we'll try to know what is this R0. And of course, for a PMMC, we know the value of RM. We know the value of meter resistance. So RM is meter resistance, Rx is unknown resistance, R0 is resistance for full scale deflection, which means that if Rx is 0, then this dial, this ohm meter will point or will indicate 0 value is the meaning. That too, the pointer should have full scale deflection. Suppose you have clockwise pointers. That means generally we go for a clockwise pointer, which means that leftmost side will be 0 and rightmost side will be having some deflection. That means a PMMC without any current through it will show 0 or 0 scale deflection, 0 deflection. That 0 deflection will be, say, left hand side. Full scale deflection will be on right hand side. This is what I meant by clockwise deflection meters. So if we consider such type of meter, now for our condition, for the circuit shown here, the meter pointed will be deflecting to maximum or full scale for R0 and Rx is equals to 0. That is the reason why we have subscript like 0. Here 0 means the resistance of unknown which is connected is 0. Then R0. Now V is the battery voltage. So let us see what is the meter current. Because all the resistances are in series, meter current is pretty simple. It is simply I is equals to V by overall resistance. Because all the resistances are connected in series, we have the equivalent resistance as sum. So Rx plus Rm plus R0. This expression should give us the current through the meter, and accordingly we will have deflection in the meter. Suppose Rx is equals to 0, then the current is going to be V by Rm plus R0. So say this is the dial. So say you have dial like as shown here. So say I'm having a pointer. Generally PMMC clockwise meters means when no current flows through the meter, it should be showing leftmost side. As current through the meter increases, the deflection will be uh, moving. The pointer will be moving clockwise as shown in the figure. Can you see that? As current is increasing, the pointer will have full scale deflection. So for maximum current value, the pointer will show full scale deflection. If current is decreasing, the pointer will move in anti-clockwise direction. If current value is completely 0, then the pointer will be in 0 deflection position, or say leftmost position as shown in the figure. Now, how do we calibrate our basic meter for the basic circuit of ohm meter? So let us have the initial position of the basic meter. It is actually should be at leftmost side. Now, what happens if Rx is equals to 0. For the circuit shown, there, for the circuit shown, if Rx is equals to 0, which means that we'll have to short circuit this. Zero resistance means it is short circuited. Let me just overwrite on it. So Rx is 0 means we have simply short circuited it. There is no resistance, so which means that Rx is equals to 0. For Rx equals to 0, then we have seen the current through the circuit is simply V by R0 plus Rn. Now this is the current flowing. Now for such current, what we do is, the current is maximum. So when we don't connect any resistance to the meter for measurement, when we simply short the terminals, say here we'll name it as A and B terminals, which means it's zero resistance. So zero resistance is when we'll have maximum value of the current through the basic meter. Now at that time, what happens is you will have maximum deflection of the meter, or that is what we call as full scale deflection of the meter. So this is the position of the pointer for the circuit and situation shown on the screen. So for such conditions, here we have Rx is equals to 0. So let us just point it as Rx equals to 0. That means when you calibrate the meter, this should be what value? This should be 0 value. Okay, let me mark it in black. So this should be 0 value. Now what happens if you increase the resistance value? Now I'm trying to increase the resistance value. Then if Rx is increasing, our total current is going to be like this. So this value is also increasing. The denominator is increasing. So the whole simplified answer of current will get reduced. As current is getting reduced, the pointer will move towards left side because current magnitude is getting reduced. So what we'll have here? So we can see that the pointer is getting reduced. So this is how your scale is going to be reversed. So as the pointer is getting reduced, which means the resistance value is getting increased. So as Rx value is increasing, the pointer will try to move in counterclockwise direction. So our scale is going to be in this manner. So if here it is 0, here it will be some other ohms, which is greater than 0. Here it is greater than the previous value, it is greater than previous value. So as Rx is increasing, your pointer will move in counterclockwise direction. Now what happens if A and B is open? If A and B is open like this, Rx is infinity. Rx is infinity means current is completely 0. So when current is 0, there won't be any deflection in the meter. Hence, we can simply say that when there is no deflection in the meter, it means that resistance value is infinity. So our scale will be 0 on the full scale deflection of the meter and infinity at 0 scale deflection of the meter. Now as Rx value increases, you will have pointer moving. That means scale will be increasing. So it is say 1, 50, or some like that, 100. This scale is completely not uniform. Hence, I couldn't write the uniform scale here. This is how our basic ohm meter helps in measurement of resistances. You can see our bottom line concept is again Ohm's law. So knowing the meter resistance Rm, the resistance of full scale deflection R0 can be found. So how much R0 we have to place in the series circuit of ohm meter can be decided with the help of Rm and checking out for the deflection in the PMMC meter. Then the pointer on the scale is marked as 0 as we have seen earlier. Now, if Rx is infinity, the terminals across Rs is open and the deflection is 0. The scale is marked as infinity. That you have seen here already. So we have 0 on rightmost side for full scale deflection of the meter and infinity at 0 scale deflection. So we have completely inverse scale. Before using the instrument, the leads must be adjusted to set the deflection to 0. So this is an important check we have to do before using the instrument. So the leads must be adjusted to set the deflection 0. That means this side. The scale is an inverse scale and the scale is highly non-linear. It is not linear. It's not a uniform scale. The ohmmeters are classified into two groups as shown below. So far we have seen the construction and working of basic ohmmeter, how the concept of Ohm's law used in measurement of resistance, how without calculations directly by checking the meter, how can we note down the resistance value, and that setup we have seen so far. And we can have the classification of ohmmeters as series type ohmmeter and shunt type ohmmeter. We are going to see the series type ohmmeter and shunt type ohmmeter in our next class. So far, what we have seen in this video lecture. So far, we have seen what is a resistance. We have revised what is a resistance, and we have seen different classifications of resistor element. And in perspective of measurement, that means measurement point of view, what are different types of resistances we have seen? How do we categorize? Like low 0 to 1, medium 1 to 100 kilo ohms, and high more than 100 kilo ohms, like that. And we have seen different methods to measure low resistance, medium resistance, and high resistance. We have also seen examples of low resistance, medium, and high resistances. And we have discussed that Ohm's law will help us in measurement of resistances. Taking that into consideration, we have seen volt ampere method, which is also called as voltmeter ammeter method. It can be used for measurement of low resistances to greater than around 0.5 ohms and till medium resistances also. So we have seen the circuit for volt ampere method, and we have seen how to calculate the resistance, and we have also seen the a basic ohm meter circuit, which uses a permanent magnet moving coil, and we are just trying to um, use a permanent magnet moving coil meter to indicate the resistance values in an intelligent manner. We just had a Rx resistance and meter resistance. We know it will be there with the permanent magnet moving coil. And how to choose the value of Rx, R0. Rx is an unknown resistance, R0. So R0 is chosen in a manner that when there is no Rx, your pointer should be deflecting to full scale. So in such a manner, we have to select the RS. It can be decided easily by knowing the R0 value, by knowing the meter resistance. And we have also seen the working of ohm meter and how the scale going to be. It is going to be inverse scale. That means rightmost will be 0 and leftmost will be infinity. And we have seen that there is a voltage source used, and voltage source should be constant. That is an important point to be remembered. V should be constant. And then we have also seen the classification of ohm meters. In our upcoming video lectures, we are going to see the construction and working of series type ohm meter and shunt type ohm meter. Hope the session was useful and you understood the concepts that were explained in this video lecture. Let us the expected optimistic learning outcomes of this video lecture would be the listener should be able to classify the resistance in low, medium and high values, giving examples for each. And they should be able to list the methods of measurement of low resistance, medium resistance, and high resistances. They should be able to draw the circuit diagram of basic ohm meter, and they should be able to explain the working of basic ohm meter. So we don't have a special meter or a special meter with different working principles used here for a basic ohm meter. So we just tried to recollect again that we just used a simple permanent magnet moving coil instrument which deflects proportional to the current flowing through it, and we just have that PMMC in series with some R0 resistance and series with unknown resistance which we want to measure. And we use that simple technique, and let me go to the slide again. This slide. Here, please don't get confused that it is a capacitor. It's not. It is a resistance. So let me join it. It is a resistor. Here we have placed the arrow mark. It states that this resistor value or resistance of this resistor is dependent on meter resistance. Before going for measurement, we have to make sure that there is full scale deflection when we short circuit these two leads. So the leads of the ohm meter are going to be we have a meter here. You have some ports here from where we can have, these are terminals here. So what are the two terminals that are coming outside from the circuit is what we are trying to see now. Here, the meter terminals would be these two. So these two are meter terminals to which we have to connect. So if you want to measure some resistance, say here you have a resistor and I want to know the value of this resistor Rx, then I have to simply connect this way. Now, before using this ohm meter for measurement of Rx, what I have to make sure is I'll take a simple wire, I will short these two terminals and I'll cross check that this deflection, it should be full scale. So here you have 0. So the pointer should be indicating 0 for such type of connection. We have to make sure of this. Once it is deflecting to 0, then the meter is fit and fine for usage. Then what we do is we simply connect Rx between the terminals and we see that there will be some deflection, and because it is calibrated taking different values of Rx already, known resistance is already, we calibrate the scale of the basic ohm meter, and hence you can know any value of the resistance to which it is connected to. Hope you are clear with the concept of ohm meter. So hope this session was useful and you have understood all the concepts explained in this video lecture. Thank you so much.